Hi, welcome to Physics 3B. My name is Alan Nickel, and I'm the instructor for the course. Many of you are continuing on from Physics 3A here at Laney, and we also have quite a number of students who are coming in from other schools. So I am looking forward to this semester. We're going to be hitting a lot of topics. As you guys know from Physics 3A, we move pretty quickly through the topics and through the textbook. Here is the textbook for the course, Physics 4, Scientists and Engineers with Modern Physics. And we're going to be finishing out the textbook this semester. So in this video, I want to go through the syllabus for the course and through the schedule of what we'll be doing this semester. So let's take a look at the syllabus and we can see what we've gotten ourselves into. So let's take a look at the syllabus for the course. Again, welcome to Physics 4B. My name is Dr. Alan Nickel. We've got quite a list of topics. Now you guys have been through Physics 3A, so we hit a bunch of topics there too. But for Physics 3B, we'll be looking at electric forces and fields, magnetic forces and fields, and we're going to see how those are related. They're really all part of one unified package, electric and magnetic forces. Along the way, we're going to be looking at direct current circuits, alternating current circuits, DC and AC. We're going to be looking at light, different properties of light. We're going to have to do a little bit of relativity because a lot of the stuff that we learned in Physics 3A works really well as long as things aren't moving really fast. But as things end up with higher and higher energies, moving faster and faster, we've got to develop a new set of formulas for keeping track of things like kinetic energy and momentum. And so we're going to be doing a little bit of relativity. And then we're going to head into quantum physics, and that's going to be a big portion of the course. So quantum physics, we're really looking at the physics of fundamental particles. We'll look at individual protons and electrons and neutrons, what are their properties. We're going to be looking at atoms and molecules and nuclei. So a lot of really interesting topics. And here is the syllabus. So we'll say this is the syllabus here on the left side. This is a bunch of homework problems. And again, way too many chapters, right? It's a lot of chapters. And then there are the homework problems that are being assigned. So make sure that you're staying caught up. That's so important in these physics courses. Make sure that you are staying caught up with all of the homework problems. You're working through the examples, reading through the material, listening to the discussion of the material. Those are going to be really important. But at the end of the day, you've got to be able to show that you can set up different kind of situational problems and solve them. And so those are really the skills that you want to be able to develop. So it's going to depend on a conceptual understanding of, how do the different ideas from within physics, how do I bring those together? But for each of those topics, there's going to be a set of formulas that apply. And you got to have both parts. The formulas alone, without having some kind of an understanding of what all these formulas are referring to, it's not very useful. So you want to be able to have a conceptual understanding in order to select and set up the formulas that you're going to work from in a given problem. So again, here are all the homework problems. We're going to take it just one chapter at a time. The semester is 16, 17 weeks long. And so we'll do it. We'll make it through all of these topics. As far as the syllabus, here's my name. Here is my email address. Now for right now, office hours, at least for the syllabus, just to get everything started for the semester, I've got these listed as Monday and Wednesdays. I've got some other classes on those days from 9 to 10 and 12 to 1. And then Tuesdays and Thursdays from 11 a.m. to 1. Now our class is completely being taught remote. And so our office hours on Tuesdays and Thursdays will be through a Zoom, Zoom, which is set up within Canvas. So one of the most important things you want to do with Canvas to get started, take a look through Canvas, look at the modules, and what you'll find is right at the top of the modules, there is a module, well, the very top module is Getting Started, and that's where you are currently. And then right below that is Office Hours. So Office Hour links will be posted there. So if you go to the Office Hours module, there's going to be a listing of the links in order to come into Office Hours, the Zoom meetings where we'll be holding Office Hours. And so make sure that you have found those and you know how to come by Office Hours. Now, the other office hours, the Monday and Wednesday office hours that we have set up right now, those could move back and forth depending on the circumstances for this semester. It could be because of the pandemic situation. There could be times where those office hours are also being held through Zoom meetings. So, and that's why what I want to encourage you guys to do is I'll be sending out email updates throughout the semester and letting you know what the current set of office hours are. And then you can also go to the office hours module. And again, there will be links. If there's any Zoom office hours that are being set up, those will be listed there. So these other office hours could move back and forth. Sometimes they could be on campus during times of the semester, but there could also be other times during the semester where those are also being held remotely. And so that lets you know whether to look for me on campus or whether to go online for those office hours. Now, the prerequisites for the course, you've all successfully completed Physics 3A. Good work. I know that it is a lot of work getting through these physics courses, so congratulations on that. And then also Math 3A, which was also a prerequisite for Physics 3A. The textbook, I think it's around here somewhere. I think I already showed this once, but how many? It's always good to see the textbook. So here's the textbook that we're working from. It's the same textbook that we used in Physics 3A, if you were taking 3A here at Laney. Giancolli's Physics for Scientists and Engineers, 4th edition. I realize this textbook comes in different versions. And so what you want to make sure is that you've got a version of the textbook that goes all the way through chapter 44. Now, the way that works in terms of the title is Physics for Scientists and Engineers with Modern Physics. So the with modern physics indicates that the chapters continue all the way through chapter 44, which is what you're going to need for the course. So make sure your textbook includes this full list of chapters. Let's see, so that's the textbook. Any questions on any of this stuff? Just let me know. Let me know if you've got any questions with any of the items that are coming up here. The lectures are officially listed as Tuesdays and Thursdays from 1 to 2:50 p.m. Now, everything is set up remotely, and so this course is basically asynchronous. You'll be watching the lecture videos by going into Canvas. So there are no Zoom meetings for the day-to-day classes. So you can actually view those lectures at whatever times you want. So whatever times work. Now, I have set up office hours so that whatever questions come up in lectures, you're able to stop by office hours and ask those questions. So again, everything is on Canvas. Everything has been recorded. So everything's been video recorded, all the lectures, all of the lab exercises, everything is on Canvas. And if you take a look at the modules within Canvas, what you're going to find is right at the top, there's the Getting Started module, which you guys are currently watching, or you're working from. And then right below are the office hours, and then we go into the chapters of the textbook. So you'll see within module that the chapters are all listed. For every chapter that we look at, there's going to be, I think almost for every chapter, I think there's one exception here, but I think every chapter has 2 videos, a couple of videos, basically 50 minutes in length, roughly, something like that. So it's the equivalent of an hour of class time in a traditional classroom setting. And so it's set up so that you guys can do the first hour, and then you can take a break for whatever time you want. I mean, in a classroom setting, we would take a break for 10 minutes and come back and then do the second hour. And so here, you're going to be able to, for each one of the chapters, go through and watch those videos. I think the exception here is chapter 21. There's a lot of stuff in chapter 21 that introduces electric forces and electric fields. I think there are 3 lectures there, and then chapter 22 only has 1, and then after that there's 2 lectures with each one of the chapters through the entire course. Laboratory also has an official time to it, but we're not going to be meeting during that time. So again, this is also asynchronous. Now, if you go into the modules, if you scroll all the way down through the modules, all the way past chapter 44, there's going to be a bunch of modules, one for each chapter. There's going to be a module for each of the midterms and the final exam. If you scroll all the way down, you'll reach the labs. So I placed the lab modules at the lower end of all the modules. So the labs are at the very end of the modules, and so scroll down to those, and what we'll be doing is we'll be doing a laboratory exercise each week. So what will happen is that there's an official time scheduled for those laboratories, and again, what you want to do is make sure that you're staying caught up. So make sure that you're paying attention to the schedule. So let me jump ahead here and actually take a look at the schedule. So here is the schedule for the entire semester. So what you can see is that each day, or each week rather, we have, officially we have 2 meetings that we would have for classroom if we were in a classroom setting. And so I structured the course the very same way. So for the first week, there are 2 dates that are listed, and you'll be looking at chapter 21 and chapter 22 that first week. The next week is chapter 23 and 24, and then 25 and 26. So pretty much each official class meeting, we're looking at one particular topic. Then what you'll find is once every 4 weeks, what we do is we'll have some review classes, some review lectures, some review videos, and then we'll follow that up with a midterm. Now the midterms are scheduled at the time of the official class. So if we go back and think in terms of this class time, 1 to 3 p.m. on a Tuesday or a Thursday, we will have midterms that are taken during that time. All right, so that's the one time when everybody meets together at the same time, or everybody is taking the exams at the same time. So I'll be sending out the exams, making those available at 1 p.m. and then at 3 p.m. you will finish work and you'll return those exams to Canvas. So all of the assignments are being submitted to Canvas. All of the lab reports and all of the midterms and the final exam will be submitted to Canvas. Now there's a set of homework problems here, and I think to be successful in the course, you're going to need to make sure that you have a pretty good understanding of how to set up and solve these types of problems. So remember, when you're going through the homework, you're not just trying to learn how to do that particular problem, but you're thinking of this more generally. You're thinking of this as, what am I learning from this problem, so that if I get a similar problem, not identical, but a similar type of problem, how am I going to be able to go through and set it up? And you guys are experts. You guys have successfully made it through Physics 3A, so you kind of know what is required to be able to successfully complete the midterms and the final exams. So make sure that you're doing the homework. Now the homework doesn't figure into the final grade. So I don't collect homework. That's not going to be submitted. If you look at the grades are going to be based on the midterms, the final exams, and the labs. So during the course of the semester, we are going to have 4 midterms. Those dates are already set right here. Each one of the midterms is going to cover 3 or 4 weeks of content, which works out to be 6 chapters in the book. So each one of those is going to be covering those sets of topics, and each one of those individual midterms will make up 15% of the final grade. The final exam is 20% of the final grade, so the midterms are each 15. 4 of those midterms combined add up to be 60. Now, I don't drop any of the midterm exams. So I know in some courses it's possible, if one of the midterms doesn't go well, to drop that and replace it with some other score. But and I've tried that in the past, but what I found was that, I guess the feeling here is that all parts of the course are important. And I want to make sure that when we are looking at the exams, the midterms that you guys are taking, that they represent the full coverage of all of the topics that we've looked at. So I'm not going to drop a midterm. Now, if an absolute emergency comes up where you can't take a midterm at the scheduled time, let me know as soon as you know that's going to happen. So in most situations, students kind of know coming up if there's some kind of a scheduling conflict, for example. Now sometimes there's an emergency where you really don't know until maybe the day of the exam or something, but as soon as you do know that you've got a possible conflict that you might not be able to attend or participate in one of the midterms, let me know as soon as possible. We can schedule makeups, so scheduling a makeup is doable, and that's what we want to take care of. But again, plan right now to take the midterms on the scheduled dates. If there's an absolute conflict, or if there's a reason why that can't be done, let me know as soon as you find out. Same applies for the final exam. Let's see, so we're going to have each of those midterms worth 15%, the final 20%, and then the remaining 20% of the final grade will come from looking at the lab reports that you submit each week. And so with the homework, there's an assignment for every chapter. You are encouraged, actually, to work together in groups. So one of the best ways to learn this material is to discuss this with other people. And so if you're in some kind of a discussion group or working together on homework problems, talking back and forth about what's going on in a homework problem, how should we set this one up, that's a great way to really learn the content or the material of the course. Now, what happens sometimes is that students are working together in groups, but they're not making sure that they really have an independent understanding. And that's going to be key, because when it comes time to take the midterms and the final, those are going to be doing independently. So we certainly want to make sure, each individual student is acquiring these skills and is able to set up these problems and to be able to solve these problems on their own. So when you're doing the homework and you are working together in groups, make sure that you're able to go off on your own and independently set the problem up, carry through the algebra, come up with the whatever the problem is asking for, solve for those values. So make sure you can do this independently. Now with the lab work, kind of the same thing. You can certainly be working together with other students. I highly, highly, highly recommend make sure that you are putting together your lab reports independently. Lab is one of the parts of the course where sometimes students are hoping they're just going to get by maybe working from lab report items that other students have put together for them. Don't do that, because on the midterms, questions are going to come up that are going to check your understanding of what we've done in lab. So really, independently, understanding what you're doing in lab is going to be very important. Another issue that comes up from time to time is that, maybe somebody is writing up some of the lab, maybe there's some graphs that need to be done for the lab, for the labs. Those are getting passed around. Maybe one person does that work and kind of passes it around to other people. And what I find is, a lot of times there are errors in that. And if I start to see that, the very same set of errors is being passed around, then that lets me know that you're not doing your own lab reports, that material is just getting copied from other students. And again, don't do that, because you're not going to learn the material. You're not going to be able to pick up the skills that you need by copying material that other students have done. So if you get stuck in writing up a lab report, stop by office hours. We can certainly look at whatever questions you have. And we can also take a look or work with other students and find out, how are they making those graphs? And how does the lab report need to be formatted? Now, the lab reports, let's see if we move back here. What we'll see on the schedule is that there's a lab scheduled each week, right? The lab reports are going to be due the following week. So lab reports are going to, and if we take a look at the labs are scheduled for Tuesdays. And so officially, our first lab is January 25th, the first week of class. January 25th, we have a lab report. It's looking at measurements of the electric force. Now, if we're doing the lab this Tuesday, then the due date for that lab report will be the following Tuesday. And what I'm going to highly recommend, what you really should be doing, is thinking in terms of starting the lab here. So for lab number 1, start that the first week. Don't wait until it's due. So this is one of the most most concerning issues that comes up in these classes, is that at least early in the semester, a lot of students are trying to do the lab reports the night before, and they're finding out that they don't have time to ask questions. They're just kind of writing things up as best they can figure them out. Now, if we were on campus in the lab room doing these labs, you guys would be asking questions throughout the lab. I would be going around the lab room and checking to make sure that students are understanding each step. If you're trying to write up a lab report the night before, that undermines that sort of a process. So I would say, the first lab starts right out that first week. Start looking at that lab, and stop by with whatever questions you have. Now, what is going to happen with the lab reports is this. With the lab reports, what we're going to have going on is if you go into Canvas, there will be a data sheet and there will be a video for each lab. So what I've done is I've gone into the Laney lab room and I have made videos of kind of the presentation in the lab room, and then I've also made videos of myself setting up the labs and taking the measurements. So as much as possible, I've tried to give you guys, through the videos, I've tried to give you guys the feeling as if you're right there. So, you know, if we're taking measurements of something that we're heating up, we've got a thermometer in there and we're reading off the thermometer. So we're actually doing, you know, I'm doing those measurements and then I'm making the data that I've collected available to you guys. So I'm kind of like everybody's lab partner for this. So watch those videos and imagine yourself in the lab room taking those measurements and collecting that data. So if you look at the lab modules within Canvas, what you'll find for each lab is that there's a lab video showing the presentation of the lab, kind of an overview of what we're going to be doing for the day, and then that's followed up with me taking a bunch of measurements. There's going to be a data sheet that shows the data that I collected, and then there's also a set of slides that you can watch and follow along with the video. So for each one of the videos that I've set up, all of the lecture videos and all of the lab videos, there is a set of slides, a set of notes that I'm using for those videos, and you'll have a copy of those in Canvas so you can follow along and you can take notes if it's lecture or lab. You can write in whatever comments you want to write in on that set of notes. Okay, so that's the intention, is to simulate as best we can being right on campus, both for the lectures and for the lab activities. All right, so that first lab is going to be due February 1st. The second lab would be due the following week. This lab is going to... So that's the pattern that we're going to set up. The lab reports are going to be due the following week. Please get in early. Get those lab reports written up. Whatever questions come up, ask me, right? Stop by office hours and let's get those questions looked at. Let's see, I think we're through most of the topics here. Let's go back and see if we've got everything covered. One thing I do want to mention too is if you guys find anything that's missing in Canvas or anything that's been mistakenly placed there, let me know right away. So I've gone through and written up a set of lecture notes, a set of lecture slides that I've posted. I've recorded videos of all of the lectures. If you find out that some of the lectures, what I've done is I've posted those to YouTube and then linked those into Canvas. So if you find out that any of those are mistakes, and this has come up in a couple of times already in some of my other classes, is that, you know, maybe the wrong lecture gets posted in the wrong location, or check the examples that we're looking at in lecture. So for all of the lectures, I'm going to be going through and presenting examples, you know, present a new topic, and then we'll look at some examples of setting up problems and solving those. And if you find any errors that I'm making, please let me know right away so I can get the correct video posted there, or I can get the examples, the calculations on the examples of the formulas corrected to help out with the rest of the class. I really appreciate that when students let me know if something's gone wrong within Canvas. So with Canvas, what we're trying to do is get an entire course structured and organized and set up. And you know, I'm hoping that I haven't introduced any difficulties, but there's probably a few errors lurking out there. So watch for those and help me out. Let me know if there's an error that you find. So again, everything is scheduled. I'm going to let you guys know that I'm fully expecting that we will stay right on schedule. So students that were in Physics 3A, for example, here at Laney, know that I think in Physics 3A everything happened on the day we said it would. So there were no delays. We covered all of the chapters, all of the topics that we set out to cover. We did them all. And so when you guys transfer, when you guys move on to your four-year schools, you want to be really well prepared. And that's something that, you know, I hear back from students who have transferred, and they're pretty happy. You know, it turns out that when they've transferred to the four-year schools, they feel like they were well prepared to move right into upper division work. And that's what you want to do. You don't want to try and somehow get around learning these topics. You really want to get in and embrace these and learn the material, learn the content of the course. It's going to make it so that you're really well prepared moving forward with your other coursework. All right, days for the midterms, days for the finals. I think I've already pointed out that maybe the most important thing to tell yourself right now, starting out with this course, is I am going to stay caught up. I am not going to fall behind. I am going to pace myself through this course. When the schedule says we're on chapter 27, I'm going to make sure that I am on chapter 27 and staying caught up. Try to stuff everything in the night before an exam, or trying to write up a lab report the night before it's due, is just not going to work well. And that can kind of accumulate. So don't let yourself start falling behind. If you've got any questions or any concerns at all, stop by office hours. So I find that the students stopping by office hours and they're bringing in questions and we're looking at them, pretty much let me know that that has worked really well. That by staying caught up in the course, stopping by office hours with whatever questions come up, they're able to keep themselves caught up in the course. If you do fall behind, stop by office hours. I'm not gonna worry if you come in and you're asking questions about, you know, 2 or 3 chapters before. That's fine, not a problem. I guess we'll just wrap things up. Here's the schedule for the midterm, schedule for the final exam. Let me talk a little bit about grades here. So we already talked about the fact that you are required to do the homework, but I'm not going to grade it. In fact, there are solutions manuals out there. You can search for solutions manuals or talk to other students. They're out there online. I would encourage you to get a copy of the solutions manual for our textbook so that you can check yourself as you're working through the homework. You're very welcome to stop by office hours and ask whatever questions you want. But what students also find useful is if they have their own solutions manual, they can kind of check their solutions on their own. Now, if that doesn't make sense, then definitely stop by office hours. If you're looking at solutions manual and you're looking at how they've set up the problem and solved it, maybe it still doesn't make sense. And that's what we're after. What you guys are after is really being clear about how to set up and solve the problems that we have in the course. Now, the grading scale for the course, I've set it up so that 85 to 100 is A, 70 to 85 is a B, 50 to 70 is a C. Now, some students say that, wow, that just seems so lenient. That seems like, but I think what you guys are going to find, and maybe you're already starting to see this in some of your courses, certainly by the time you've transferred to a four-year school as a science major, what you're going to find out in your biology classes and your chemistry classes and physics classes and whatever is that grading scales tend to be a bit different in many or most of those classes. What you may find out is that the grading scale that we have here, I'm going to say, probably represents what a lot of the grading scales are in those courses. And it's not that the courses are easy, it's that the courses are intentionally set up so that, you know, the midterms and the final exams are going to be challenging. And so if, for example, you've come through the course and you've maintained a 50% average, that takes a lot. Okay, that's not a trivial thing to be able to maintain at least a 50%. Now, 50% is not going to get you an A or a B in the course. You're going to have to do better. But that's kind of the reason behind the grade scales that I've set up. So be aware, on the midterms or on the final exams, you know, maybe the averages are in the 60s. That's to be expected. We typically, you know, we don't have a bunch of students that are getting 100 on the exams, or even in the, say, the high 90s or in the 90s. The grades are really spread out. Now, in addition to the midterms and the final, there's this 20% coming from your lab reports, and what I always highly encourage students is use those lab reports as a way to help boost your grade. If you get in early with the lab reports, write up the lab reports in a very clear manner, and you'll be able to get that 20% of your grade kind of locked into place. So if you can get 9s and 10s on the lab report, so the labs are graded on a scale 0 to 10. If you get like 9s and 10s on the lab reports, then the exams, the scores on the exams could slip a bit, but you're still going to be able to maybe get an A or a B in the course. So for example, sometimes students, maybe they take the first midterm and they get like a 65. And they think, oh my gosh, I'm failing the course. I got a 65, and that's not the case at all. What's happening is with, say, a score of 65 and excellent work on the labs, you might be pretty close to the B range. You might even be in the B range if you're getting like 65s on the exams, but you're getting 10s on all your lab reports. Okay, so that's something to really work towards to help out. Now, what also happens during the semester, and this is, I guess I understand how this happens, is that some number of students in the class start to not be turning in lab reports. So maybe they turn in a couple lab reports, but then after a few weeks, the lab reports stop. And I send out reminders. I'll be sending out weekly updates for the course. I don't want to overwhelm you guys with emails every day. But once a week, I'll send out a reminder. And, I do try and remind students that make sure that you're paying attention to your lab reports and getting those turned in. Because it's such an important part of, it's such an important part of the course, and it will have an impact on your grades. So anyway, whatever questions you guys have, let me know. Now I'm guessing there are going to be some questions that come up due with lab reports. I think what I'm going to do is for that first lab, I'm going to go ahead and discuss some of the issues with lab reports. So I'll add something onto that first week in lab and go ahead and discuss a little bit about lab reports and what the format should be, is what I will be doing. So anyway, welcome to Physics 4B. Let me know however I can help with you getting through the course successfully. And I'm looking forward to working with all of you this semester.